All right, let's start discussing chapter 26, which is the standard client-server protocol. We will talk about World Wide Web, www, and HTTP, FTP, and electronic mail, and secure shell, SSH, and domain name system, DNS. Introduction. The application layer provides services to the user. As we know, to use the internet, we need two application programs to interact with each other, two computers, each one in different location. The two programs need to send messages to each other through the internet infrastructure. We have two paradigms, the client-server paradigm and peer-to-peer paradigm. Client-server paradigm consists of two parts, a client and a server, as we know. A client is a program running at the client's end that initializes the communication by sending a request to a server, as we know. And the server is another application program that waits for a request from the client, which is running on another location. So the server is always on and always waiting for requests from clients. Examples for client-server paradigm is this. This server, and these all are communicating or connecting to the server. Worldwide Web, www, and HTTP. Here it's mentioned heuristical information and why it came and so on. And what was its provide essentially, and so on. There's nothing important here. All right. Assume we need to retrieve a scientific document, file A, which is this file A, and one reference to a large image, image B, and another file text, which is file C. Here it shows you the procedure like this, the clients, and here we have two web server. The clients first send a request to get a response that I want the request is I want file A, so it sent the server sent the file A to the client. Then he asked for another request. I want the image, which is B. Then the server responds and give him the image. Then he gave a request not to the server 1 because it does not have the file C that I want now. So I will send a request to a file to a server 2 that have the file C. Then it will respond to me and give me the file C that I want. Worldwide Web, www, web client browser, controller, client protocol, HTTP, FTP, SSH, SMTP, presenters, HTML, JavaScript, and Java. Web server, the web page is stored at the server, responsive to the incoming request. Information about web client and web server. Uniform resource locator, URL. A web page is a file, needs to have a unique identifier to distinguish it from other web pages. To define a web page, we need the identifiers, a host, port, and a path. So we'll have three things to distinguish URL from one to another. A host, the IP address of the server, or the unique name given to the server, which will be given by the DNS, and we will talk about it more later. And the port, of course, a 16-bit integer is normally preferred for the client-server approach application. For example, port 80 is used in HTTP protocol for accessing the web page. And also the path identifies the file's location and name, and so on. Before defining the web page, an abbreviation of the protocol is needed to tell the browser what client-server application we want to. We have two types: HTTP, Hypertext Transfer Protocol, and FTP, File Transfer Protocol. We will see more about them now. But first of all, let's see how what's the pieces of the URL. First of all, the port, which is optional, and a path. So we have the protocol, then the host, then the path, and the port usually is not written, but it's optional. So here the protocol it is HTTP, and the host is this, and then the path we have, which is the path. All right. So no port mentioned here. So they are using the first type, not the second. You can mention the port, of course, but as I said, it's optional and usually not written. Web document. The document can be grouped. So we have three group of web documents: static documents, dynamic documents, and active documents. Hypertext Transfer Protocol, HTTP, is used to define the rules how the client-server program can be written to retrieve web pages from the web. So the client sends requests, server return a response, server uses the port number 80, client uses the temporary port number, HTTP uses the services of TCP, which is a connection-oriented and reliable protocol. All right, uses TCP. Client initialize TCP connection to the server with port 80. Server accept TCP connection from the client. HTTP application layer message exchange between the HTTP client and HTTP server. TCP connection is closed. So TCP is a connection oriented. So that's why it's have opening handshake or open connection and also close connection, and it's reliable. And we have two methods when it comes to connection oriented. We have non-persistent connections and persistent connections. Non-persistent connections, one TCP connection is made for each request. So each time I want a request, I will open a connection and then I close, and then I open. If I want another thing from the server, I open another connection and then I close it, and so on. The client opens a TCP connection and sends the request. The server sends the response and closes the connection. The client reads the data until it encounters an end file or marker. It then closes the connection also. And if he wants another file, he will repeat these steps again. So here is an example. First handshake, the client tells the server that I want to open a connection. Then the server responds with a second handshake. Then the client with the third handshake plus the request, and the request is a file or an image and so on. Then he gets the response from the server, which is the file. Then we close the connection. So the client initialized the closing session, and then the server acknowledged it. Then the client closed it. Then if I want another file, I will open a connection again. So we will have the same steps: first, second, third handshake plus the request. Then I will get the response. Then I will close the connection, and so on. This is non-persistent connection. In persistent connection, the server stays open uh, until a period of time, then it closes, or if there is no interaction. The server leaves the connection open for more requests after sending a response. The server can close the connection at the request of the client or if a timeout has been reached. The sender usually sends the length of the data with each response. Time and resources are saved using persisting connection. Only one set of buffers and variable needs to be set for the connection at each site. So here is an example. I open a connection, then I ask for a request. I ask for a file, then it gave me a file. Now I won't close the connection. I will ask for another file and so on. Then I will close the connection when I'm finished, or when a time out has come with no interaction. It will close also. We have here the format of the request and response messages. So usually the request line has a method, then a space, then a URL, then the space, then a version, then a carriage return. You can see the abbreviation here. Then a line feed, which means another line. The header lines, we have the header name, then two dot columns, then the space, then the value, and so on. Then the blank line, then the body of the request. Here is the request message, and here is the response message. There is a difference in the response message with the method. Here it have in the request to have a method, but in the response it have the version. Here it have the URL, here status code, here a version, here a phrase. So there's difference between the two. We'll see now how it looks. Here is the method like this. This is the method. He mean by this, like you can read it, get and hit and put post and so on. You can read the description of it here. HTTP status code, which means the status code here. Usually the 200s are success. We mean by it a success. 300s are redirection, and 400 and 500 it's error. Maybe you want to memorize the common ones, which is the 200, the 400, the 404. I generally know about these three, the general rule, and maybe you can memorize these three. And the request header names, which means header names. We mean by it this. You can read it also and know more about it from here. And here the response header, which means here the header of the response. It will be here. You can read it and also understand it. It has a description. So here is an example of how it would look. We mean by this, how it will look in action. So to look like this, he will ask for a get, then the URL, then the, what was it? The version. Yes, the version HTTP 1.1. Then he will accept, he want to accept the image and GIFs and also JPEG. So he will ask for get. Then we will have the, what was it? The version, then static code, then phrase. Static code is 200, which means success. Then it says okay, which is the phrase. And here it have the header names, the date, the server, the content encoding and content length. So it's the links, what type of encoding, the server, and the date. The body of the document, of course, if it contains some data or etc. Another example is the bots with the URL, with the version. It will accept all, everything. We mean by this sample all, everything. And also to accept images, GIFs, images, and JPG. And the content length is 50. And here is the response from the server to the client. As we mentioned here, the dates also the same here, the same as previous. All right, the cookies. Today, the web the web has other functions that need to remember some information about the clients. Websites are being used electronic stores that allow users to browse through the store, select one's item, put them in the electronic cart, and pay at the end with a credit card. So the concept of cookies is simply like remembering the information about the client, like login details, visitors counter, some website. Maybe agencies have some agencies to advertise. Yeah, so this is that the cookies do. The creation of cookies depend on the implementation of the time. When a server receives a request for a client, it stores the information about the client in a file or a string, such as the domain name of the client, a registration number, a timestamp, and so on, to remember it when a client come back again to the same web. The server includes the cookies in the response that it sends to the client. We will see soon with an example. When the client receives the response, the browser stores the cookies in the cookies directory, which is stored by the server domain name. So when you enter the server domain name again, it will you will find everything saved, and you can maybe you will find it filled in automatically because it's remember your informations. An example here, where is it? I don't know, but like he like stores your information like the session, the time, ID time, what else, and other information. It's look like this, like the cookies or the information that are getting stored. And here is an example of this. So we will first get the client will ask for a get with some things. Then a customer file is created with ID, so it created this with ID. The response, the client response, and it set the cookies. Then a vendor file is created with cookies, so the client have the cookie now. So whenever I want to request again, I will give the cookies to the server. So here I'm giving it the cookies, and the server job is just to update the exiting cookie that it has. So the cookie will remain here. It will just get updated and be given back to the, so here I got updated and I give it back to the client, and the client, whenever he requests from the server, he will give the cookie back, and the server just will update that cookie and bring it back to the client. So this is for part one. Part two, web caching. Uh, Web caching, HTTP support proxy services. A proxy server is a computer that keeps copies of responses to recent requests. The HTTP client sends the request to the proxy server, and the proxy server checks its cache. If the response is stored in the cache, the proxy server sends the request to the response server. Incoming responses are sent to the proxy server and stored for future requests for other clients. The proxy server reduces the load on the original server, decrease traffic, and improves latency. So whenever we have a response from a server, it will store it in the proxy. So next time when I ask for something, it will check first the proxy. If it's there, it will give me the response immediately. If it's not there, it will go for the wider, for the internet in general to bring that response. Then when it gets that new response, it will restore it to the proxy. So you can say it will make the, it will reduce the load and decrease the traffic. So example for a proxy server, here is the proxy server. So whenever I'm asking for something, I will check the proxy server first. If it gets the response, I will take it, and that's it. If it does not get the response, I will go for the whole internet, get that response, I will have it, and also the proxy will have it for future requests. More about web caching. Cache acts as both client and the server. Typically, the cache is installed by ISP. Uh, And as we said, why web caching? It reduces the response time for the client request, as we said. So it will get it immediately from here instead of looking for the whole internet. Reduce the traffic on institution access link to reduce the traffic. All right. Now with the file transfer protocol FTP, help when transfer files from one host to another based on the client server architecture or paradigm. The two connections in FTP has two different connections. First one is the control connection. It remains connected during the entire interactive FTP session. So it will be remain active the whole session. And the other connection in the FTP is the data connection. It's open and then closed for each file transfer activity. So it will open each time I want to send the file. It's open each time when transferring of a file is involved, and it closes when the file is transferred. Whiten connection, separation of commands and data transfer make FTP more efficient. So the control connection uses very simple rules of communication, so it won't harm the efficiency and so on. But the data connection needs more complex rules. So we will open it only when we need it. FTP uses port 21 for the control connection and port 20 for data connection. Here is an example, like the client, a local file system, the client. Here is the control connection that it's still active during the whole session, and here is the data connection when it opens and close whenever I have a file to transfer and so on. control communication, network virtual terminal, ASCII-based command sent over the control channel. Communication is achieved through commands and responses, one command or response at a time. Here is some FTP commands. You can read the command and the arguments of it and the description. There is some like maybe more important command that you need to know, like delete, list, mkday, keyday, and pass, and port. Maybe you need to know it. Store and STORE, type, user, and modify. I guess these are the important ones. Maybe you need to look at them and understand them more. And some status code in FTP, as we said. You don't have to memorize them, just have a look at them. Data connection. The data connection uses the well-known port 20, as we said. The client, not the server, issue a passive open using a temporary port, using the port command. As we said, port command, so it will use this. Where is it? Yes, this is the port command. The client sends this port number to the server receives the port number and issue an active open. So the server issues an active open, the client issues a passive open using a well-known port 20, and it received the temporary port number from the clients. So here we have just some information. File type, we have ASCII, EDCDIC, and image. Data structure, you have file, record, and page. Transmission mode, we have stream, block, and compressed. So file is a digital container used to store data on a computer or digital device. A record, a collection of related fields. Page, it refers to a fixed size block of data that's transferred between storage and memory. Transmission mode, you have a stream, continuous flow of data. Streaming data can be processed as it's received rather than waiting for the full data to be set to arrive. Block data is transmitted in large blocks or frames. Compressed data that has been reduced in size to save space or transmission time. Here's an example of the things that we took. The port 20 for data transfer process, control process is port 21. So here it says like the server is ready, the active open. Here is the passive open from the client. Pass and just give it the port, the type, the structure, and this. Then here, when we reach here, it's time for data to transfer. So I want to transfer a file or a record or etc. So I will open the data transfer process here. Then I will close, quit, and so on. So here, just telling you that all of these are control process that remain open the whole session, as you can see in gray. But the the blue one here, or green, it will just be open whenever I have a file or a file to share. So that's it. Security of FTP. The FTP protocol design when security was not a big issue, so it's not secure. Although FTP requires a password, the password is sent in plain text, so it's not encrypted, which means it can be interrupted and used by an attacker. The data transfer connection also transfer data in plain text, which is insecure. To be secure, one can add a secure socket layer, SSL, between the FTP application layer and the TCP layer. So in this case, FTP is called SSL FTP, the secure one, you can say. Electronic email. Electronic email allows user to exchange messages. The nature of the application is different from other application discussed so far. This means that the idea of client-server program should be implemented in another way, using some intermediate computers services. So that's we will have some services in between. Like here, for example, the architecture of email. You have the UA, which is the user agent, MTA, message transfer agent, MAA, message access agent. So we have Alice here. He wants to send something to Bob or an email to Bob. So it will put or push to an MTA client. Then the MTA client will send it to the MTA server via something called SMTP, and we will discuss it soon. Then it will go to a mail server. This mail server has a spool. You can think of it as a queue. Then MTA client. We will have here in between like many servers like this one, So we will have many servers until we reach this last one. So there are many intermediate servers, but here for clarification, they are just making it as a line. It will go through the internet. We mean by through the internet, like many mail server, like this one. So after the MTA client, it will go to the MTA server. Then this one has a boxes of mails. Okay. So you can say it's a container of container of users or mails. Then here we have MMA, which is message access agents. It will access by pool. So here it was the put or push. Hey, it's bad. It's bad. Put or push. Here it will be pull. And it will use, here we was using SMTP. Here we will use pop. Wow, it's bad. It will use pop3 or IMAP4 in order to transfer it from MMA server to MMA client. Then it will get to the Bob safely. And only when Bob's is online, it will do this. It will remain in the boxes. And whenever Bob is online, it will do this process from here till it reach to his device. I hope it's clear. We will discuss now the SMTP, or we will discuss it soon, and the POP3 and IMAP4, which is pull methods, and here put push methods, SMTP. All right, he is here just comparing the, you can read it. Email address, it says like to have a local part, which is you can say meow or your name or whatever. Then at this is the local part, the meow part. Then the domain name, which is gmail.com. Okay, you get it. Protocols used in emails. Now we will discuss the protocols. The message transfer agent, MTA. It's an abbreviation. No, it's not abbreviation. The formal protocol that divides the MTA client and server on the internet is called SMTP. The simple mail transfer protocol that we show them here. It's a push method. Okay. Yes, push protocol uses commands and responses to transfer message between MTA clients and MTA server, as we saw here. MTA client to MTA server using the SMTP, which is a push or put method. So here is an example. They give you a list computer and mail server, SMTP protocol, then SMTP protocol from the client to the server. Then when it receives to the Bob, it will use MAA, which is one of the techniques, POP or IMP, MP4, which is a pull method, also from a server to a client, like this, like here, from a server to a client. It will use POP3 or IMP4, which is a pull method. Here is some SMTP commands. You can take a look at it. Some responses and so on. You can take a look at it. All right. Here is the example of an email. Here is an SMTP server, SMTP client. It shows you how it's like transfer or something. It will have an envelope which contains the mail from, receptum to. It will contain the header. It will contain the body, and so on. So here it's data transfer. It says data transfer from here to here. You mean the email. Email. And here connection establish, as we discussed, like the handshake, and connection termination, also 3 handshakes. All right, protocols used in the email, also MMA and the receiver side. It's a pull protocol, as we said. We have two types, POP3 or IMPA4. You may know, you may try to understand or memorize the abbreviation. It's important. As we said here, from the server to the client and the receiver side, we will use POP or IMP, POP3 or IMP, MAP4. All right, he's discussing now the POP4 and IMPA4, and we'll tell you the differences between them. A simple but not limited in functionality, so it's weak, you can say. So the IMAP4 will be more complex and advanced. The client POP3 software is installed on the receptor computer, of course, and installed on the main server, and so on. And he's here, it's just showing you things. That is not important. IMAP4 is more powerful and more complex. As we said, the user can check the email header prior downloading it. It can search the content of the email. It can partially download the email. It can create, delete, or rename mailboxes on the mail server. A hierarchy mailboxes in the folder. So it's advanced. As you can see, it can do many things. Here we have a MIME, which is multi-purpose internet mail extensions. It's a supplementary protocol, so it's a plus. You can say it's an extra thing, optional. You can think of it like this. So it's a plus, supplementary protocol that's allowed non-ASCII data to be sent through email. It transforms non-ASCII data to an ASCII simply, and vice versa. A MIME header is added to the original email header section to define the message transform parameters. So whenever you want to use it, add it to an header. And remember, it's a supplementary, so it's not a must. And here how it's working, like content transfer encoding, base 64 conversion. All right. You can say like we will look at the non-ASCII data from right to left. So we will how it was, data is divided into 6 bits chunks, each 6 bits section, which section converted to an ASCII character. All right, we'll see how. So here we will have 6. 1, 2, 3, 4, 5, 6. What is it? Here, he already did it for me. Like, this is the first 6 ones. Then we'll take from here. Uh, Also 6, and here is it. Then we will have 4 and 2. Here is 6. He take it here, and then at the end he already have 6, so he take it here. What if it was here like 5 and the numbers are done? You can't just have 5, so you will add 0 at the leftmost. At the end, if it's not 6, you will put zeros in the left. So if the one was not there, you will put 0 instead of it. Okay, and so on. Then he convert binary to decimal. So maybe you need to watch how to convert binary to a decimal video. After you understand how to convert the binary to decimal, you will use this decimal that given in the table. It won't be given, of course. You have to memorize it, and it's easy from 0 225, it's capital A to Z, and then from 26 till 51, it's A to Z in small letter. Then from 52 till 61, from 0 to 1, then 62 plus 63 slash. All right. So here is the base 64 conversion. So here, after you convert the binary to undecimal, you get 51. Now see where is 51 here? It's here. It's Z small. So you will base conversion. So you will have Z small. 8. Number 8. It is capital I. So you will have capital I. And then what is the number 4? So you have capital E. And then 57. 57. So you'll have 5. And that's it. That's how you convert non-ASCII data to an ASCII data. You will have it in binary. You will divide it 6 chunks from right to left, 6 chunks. And if the last chunks don't have 6, it's like 4 or 3 or 5, you will add zeros at the left of it. So you'll have zeros here, 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 and so on. If it was here like 3 numbers and you miss 3, so you add 3 zeros at the left. Then you convert the binary number that you have to a decimal number, and so on, and for all of them. And when you have the decimal number, it's not the answer. You have to take this decimal number and see the table that you have memorized and see the letter that's corresponding to the code. Then you put it and you have the ASCII data. And that's it for part 2. Now we are going to part 3 and the last part. We'll talk about the secure shell and the DNS. So there is a concept of a remote logging. So you have a terminal network, which is the telnet. A remote logging protocol provides a genetic client-server pair for remote logging application. Requires a logging name and password. Telnet is not secure though. Communication. Wow. Communication protocol. So it's not secure. So the secure, you can say, version of it is the secure shell, SSH. It's a secure application program that can be used today for several purposes, such as remote logging and file transfer. It was originally designed to replace Telnet because it's not secure. So the secure shell, SSH, is the secure version or replacement for the Telnet, which is not secure. The components of SSH, you can have it like the application, and between the application and the TCP, you have the SSH, which is contained SSH con, SSH auth, SSH trans, and you can see more details about it in the book if you want. So the application, so SSH for remote logging, we have it for the file transfer and port forwarding. So you have the FTP client, SSH client, which is the local site, and the remote site that we want to do something with it, like remote logging or file transfer or port forwarding. It will be through a tunnel, which is secure connection, and it will receive the SSH server, then to the FTP server. So the DNS, now the domain name system, it's the thing that gives webs a name, so that we don't have to memorize the URL or the IP and so on. So the internet needs to have a directory system, phone book. It's like a phone book, same concept, that can map a name to an IP address. So instead of memorizing the IP, you will memorize just the name. So instead of writing the IP of Amazon, you will memorize only the Amazon.com. That's the concept of the DNS. It's the thing or the ones that give names to an IP address or web pages and so on. So here you have the user. Okay, a user. We have file transfer client. Then the DNS client. He will make a query to a DNS server and then give a response to the DNS client, and then it will have the IP address, and then it will give the IP address to the network layer. So you will just write a host name and you will get the IP address. So you don't have to memorize the IP address, just write the name, and the DNS will do it for you to get the IP address. Consists of 3 components. It consists of the namespace, available. Yes, it's the one, as I said, that give the names space. Resolvers, which is the clients, okay, that query the server about the name of space. So we are the ones who are asking about we're asking the DNS for the names of something that we are searching for. All right, here, domain name space. The namespace is the structure of the DNS database, an inverted tree with the root node at the top. So you can see the root node, which is this one. Here we have the root node, this one. Then the top level domain, which is this, and then you have the second level domain, and so on. We usually, when reading when we want to read or want to know the URL, we will start from bottom to top of the tree. So you will have computer1 dot sales dot microsoft dot com and it's usually not written, but if you write it, it's okay. So you will get this computer1 dot sales dot microsoft dot com. And if you start from sales, you will have sales dot microsoft dot com and so on. So if you start from here, congress.government, and if you start from here, it will be expenda.com and so on. So you start from bottom to top. The namespace need to be made hierarchically to be able to scale. Each node has a label. Yes, the root node is a null label written as so it's nothing, and usually written like this. Each node in the tree has a domain name. A full domain name is a sequence of labels separated by dots. So each level is separated by dots, as we said, .sales, .microsoft, .com. So each level is separated by a dot. The domain names are always read from the node up to the root. So from bottom to top. Another example of the same thing, if we start from here, a computer dot department dot top university dot edu, like this. If it starts from here, it will be from department.topuniversity.edu and so on. Hierarchy of names of name services. Okay, a domain is a subtree of domain namespace. The information contained in the domain name space must be stored. Uh, so here you have a domain. This whole thing is a domain, and also the smaller thing is a domain, and the big like this, like each container is a domain, as shown as in the figure. The information contained in domain space must be stored. However, having just one computer stored such as a huge amount of information is inefficient and unreliable. All right. I think there is something weird here. I hope. So here is explaining the concept that he was saying here, inefficient and unreliable. So the solution to this problem is to distribute the information among many computer called DNS services. We have a hierarchy of services in the same way that we have a hierarchy of names. So instead of having one server, we will have multiple servers. So the root server has its own server, then uh, these have its own server. It got a name, like we'll take it soon, I guess. Genetic domains. Yes, it have a name. It have a name. We will take it soon. So, and then at the end, the nodes also have its own servers and so on. Yes. Okay. Zones. Name service stores information about the same space in units called zone. So you can say this is a zone and the domain. The whole thing is a zone. This is domain and so on. So the zone is like a domain. Okay. I don't know the details of it actually. Maybe you can read the book for more details. DNS on the internet. On the internet, the domain name space tree can be divided into two sections: genetic domains and country domains. So, genetic domains defines register hosts according to their genetic behavior. Okay, like this, like this. Here is the labels and abbreviation. Maybe you can take a look at it. The country domain is an abbreviation of 2 letters. All right, usually. Uh, it's a country domain, section character. Yes, abbreviation of 2 letters usually. And country and genetic domains can be on the same line. So here maybe you have genetic domains, and here you have country domains at the same level, you can say. And so on. Here is showing you how to read it. So UCA.CA.US and so on. Resolvers, which mean the clients, is a host that needs to map a domain name to an address. So he's asking for a name. A resolver can be either recursive or iterative. So we have two types of resolution. So the recursive resolution, you can see like the resolver or the source ask for the local server. The local server do not have uh, the information that the client or the resolver wants, so it will forward it to another server that thinks it has the information. The server also do not have the information. It will forward it to this that thinks it has the information, and so on till you reach the one that you want. And it says, oh, okay, I have the thing that you want. Then it will go back to give the client the things that he wants, the thing that he asked for. This is the recursive method, the recursive resolution. Each server will give back to will give it to the next one that thinks it has the information. The iterative uh, the iterative what was the iterative? It will give it back to you if it won't give you the next server that thinks have the information, or it will. Actually, I forgot. Uh, I think here it just like giving giving a server going to the next server without knowing what's next server. Like just go in order or something. And when it's reaching the when it's reaching the desired server, it will then give you the information and give it back to till it's reached to the client. But here, when you ask the server and he does not know, he will pass it to the next server, but the next server will tell you to go to that server that he thinks it's know the information. So it will go to this server, and then the server say, no, I don't have it. Check number 6, okay, and he will go for number 6, okay. Check, I have it, okay. Give it back to him, and it will be given like in one like from one server. Actually, I forget the difference, but it's clear from the photo. You won't be asked like you will be asked to describe it actually. Maybe you have to look at the book for the definition. It will be more clear, or maybe he will ask you to draw it. So you will draw it like this, but I forget. I don't know how to explain it actually now. Uh, but I hope the idea is clear generally. So know the definition of these two. He might ask you to write a definition of these two, and maybe he will ask you to draw these two. So you will just like, I don't know how to explain it currently. Caching. Each time a server receives a query for the name that it's not in its domain, it's need to search its database for a server IP address. Caching is like the concept of proxy, if I'm not wrong. So reduction of the search time would increase efficiency. DNS handles this with the mechanism called caching. So whenever I know the thing that you are asking for, I will give it to you instead of searching for the DNS. DNS message consists of these things. You'll need to know these things, understand it. The query message contains only the question section. The response message includes the question section, the answer section, and possibly two other sections. So you will have here from 0 to 31, which is means 32-bit. You will have flags, identification, number of question, number of authoritative, and so on. You will have question section, answer section, and authoritative section, and additional section. This is the component of the DNS message. And this is the header. So the query message will only contain the question section. The response message include the question section. And so the response will contain all of these four, but the query will, so the response will include all of them, the four of them, and the query message will contain only the question section. Here is an example, I guess, an example of the NS lookup. You will take it in the lab. You will give it NS club command, and you will give it the URL of the web that you want information about it. It will give you back the name and the address of it. This one shows, yeah, it shows you how to use it. Like that's it. Registrar, how are the new domains added to the DNS? When we have a new domain that is not registered to DNS, how do we add it? This is done through the registrar, a commercial entity registered in ICCN. Okay, a registrar first verify that the request domain name is unique. So it's we won't have two names that we don't have two entities that have the same name. Okay, then after it checks it's unique and then enter it into the DNS database. If it's not unique, it's already there. So we won't register it for you. It's already registered, or you are choosing a name that's repeated, so you have to change it. So if it's not there, or if it's not there, it will register it to the DNS database. Security of the DNS. All right, we need, of course, we need the security of it because the attackers, they can attack with several ways. DNS can be attacked in several ways. The attacker may read the response of the DNS to find the natural of names of the site the user mostly access. And we don't want this. This type of information can be used to find the user profiles, okay? The attackers may interrupt a response of the DNS server and change it or create a totally new response to direct it, and this is really dangerous. And also the most common or the most known one, the attacker may flood the DNS server to overwhelm it or eventually crash it. So he will request or query many, he will give many requests to the server, and the server cannot handle it. Also, it will be overwhelmed and won't notice for the real request or actual request. So he just have fake requests. He won't just to overwhelm the server. So these are the three types that DNS can be attacked. So the DNS security, you can say DNS is secure, SEC technology provide a message origin authentication and message integrity. So we have an authentication to make sure that the right person is using it, and message integrity, that the message is not changing, using a digital signature. There is no specific protection against the denial of services. The denial of services, he mean the type of the flood of the DNS requests attack and the specification of the DNS security. So the DNS security does not solve the last attack, which is the flood the DNS with fake requests, with many fake requests to overwhelm it. And that's it for chapter 26.